Welcome to Talkin Science, where we dive into the science and space news. Michael Smart is my guest today as I finally get out of the studio. Well, we're here by the lake at the University of Queensland. Michael Smart is the head of research and development and the co-founder of Hypersonix. Michael, thanks for your time. Can you tell us a little bit about the company and what you're hoping to achieve?
Yes, Matt, we're a small startup company. We're all Australian technology, and we're taking some hypersonic technology that's been developed in Australia over a 30-year period, really, and we're taking it to the market, so creating real products out of the research that's been done here, world-leading research over 30 years.
Now, you've teamed up with BOC to use locally produced green hydrogen. I'm guessing that it's not the colour of the hydrogen that makes it green.
No, so green hydrogen is generated through renewable energy, essentially. So the best way to think about hydrogen actually is it's like a battery. And so the way they make green hydrogen is they use solar collectors to collect the energy, and then they essentially break down water, which is H2O, so 2 hydrogen atoms, 1 oxygen, breaks down water. And to break down water, you have to put a lot of energy into it. And so you do that, you separate out hydrogen and oxygen, and then that hydrogen has all that energy in it, ready to burn. And so really, all fuels are sort of like batteries, and hydrogen is a particularly useful one for us because it's very easy to burn and it has a lot of energy stored inside it as well.
And what's the difference with the green hydrogen to what's normally used?
Yeah, so normally hydrogen is produced as sort of as a byproduct of the petrochemicals industry, and that's called grey hydrogen because it comes from fossil fuels essentially, and so it's all about how it's generated. It actually ends up being the same molecules. It's H2. It's a very simple molecule. It's almost the most simple molecule that you can have. But it's just how it's generated, really.
Well, hydrogen's long been touted as the rocket fuel of the future, but there are ways of making it that aren't green in terms of renewable energies because the electrolyser used obviously requires power and that's coming from fossil fuels. So how does yours differ?
Well, the fact that we won't be using any, the power used to create the hydrogen is all from renewable sources. So there's a solar collector very nearby. All the energy is used to run all the equipment, but also to do the breakdown of the energy, the breakdown of water, and putting that energy into the hydrogen molecules. So it's all green.
And is it harder to produce because you need that solar or you need that renewable energy source to kickstart the electrolysis?
Well, I suppose it's harder in some ways because grey hydrogen is just a byproduct of the petrochemicals industry. It sort of just happens. You know, they're breaking down oil into petrol and other things. Hydrogen is given off. But here we're specifically going in to create hydrogen. So it's harder in a way, but it's also more directed. You know, the whole system is set up only to generate hydrogen, and so it's more efficient in that respect.
Are there any difficulties in working with hydrogen compared to normal rocket fuels?
Typically, there are 2 forms of hydrogen that are used as fuel. There's gaseous hydrogen, which is very high pressure, and then there's liquid hydrogen, which is relatively low pressure, but it's required to be kept at minus 250 degrees Celsius, so it needs to be very, very cold. Typical rocket fuels are kerosene, which is at room temperature and a liquid, but then there's liquid oxygen as well. And so it's a cryogenic fluid as well. So liquid hydrogen is sort of, the handling of it is very similar to liquid oxygen. But in a strange way, it's more safe because hydrogen is a fuel, and so to create combustion you need an oxidizer. So if you can keep the hydrogen away from any oxidizers, then it's pretty safe. But oxygen it reacts with everything. There could be one speck of dust in a pipe, there'll be a fire straight away. So actually, in a strange way, in a very direct way, liquid hydrogen is safer than liquid oxygen, but very similar in terms of the practicalities of handling it. And the difference for us is that we don't need any liquid oxygen. So our scramjet is an air-breathing engine. So we use oxygen from the air as our oxidizer. So all we have to carry is our fuel, which is actually a very small proportion of the weight that that a rocket needs when it carries its own oxidizer.
Now, you've recently signed up with Boeing to create a proof of concept sustainable satellite launch vehicle. I'm guessing hydrogen plays a big role in that.
But having an air-breathing engine saves a lot on fuel. It's just like your jet engine for your typical commercial aircraft. All you're carrying is the fuel. Imagine if a 737, Boeing 737 or some other plane had to carry the oxidizer as well. There wouldn't be room, there'd just be room for the pilots and no one else. So the fact that we can use an air-breathing engine and only carry fuel, and remember, hydrogen is very light as well. It's a very light molecule. So in terms of weight, we get a lot of bang for our buck with hydrogen. The one limitation, though, of hydrogen is because it's light, you do require quite large volumes to contain a certain amount of energy. So that's sort of the trade-off between other types of fuels with hydrogen. It's light, so you don't, it's easy to carry, but you need a bit of volume. So it doesn't work for really tiny spacecraft. It works for medium-sized spacecraft, which are the ones that we're designing in our company.
Now, we're used to seeing huge plumes coming from the rockets as they launch. Will your scramjet engines be different?
Yeah, so you won't see anything come out. You'll see a bit of light, perhaps, but it'll be a totally clear plume. And in fact, when you watch the space shuttle launch, it had 2 solid rockets on the side, but the main engine, the plume that came out of the back of the space shuttle was a liquid hydrogen, liquid oxygen rocket. And if the plume is totally clear, and all it's putting out is steam. And that's what we'll be doing. We'll just be putting out steam, so not creating any CO2 or any pollution in that respect.
And I believe in the last couple of weeks, a successful test has been done.
Yes, so we're sitting here at the University of Queensland. The University of Queensland has a world-leading wind tunnel for testing scramjet engines, where the facility can generate the exact conditions that a scramjet would experience in the atmosphere in the lab, but just for a very short period. And so we've done a series of proof of concept tests. We have an engine that can operate from Mach 5, is designed to operate from Mach 5 all the way to Mach 10. And what the test that we did here, we did 111 experiments, or shots we call them, and we basically tested the same engine at Mach 5, and then Mach 6, Mach 7, Mach 8, Mach 9, Mach 10. So we did like a production run of the engine, and with hydrogen fuel. And we'd never actually done that before. So it was very satisfying. We got some great results, and we actually learnt quite a bit about it. Particularly at the higher speed end, we actually learned a few new things about the engine, which we're still trying to understand the details, but they were good things, and we just want to understand. Whenever you get a good result in an experiment, you need to understand what it is. It's not just about getting a good result. So it was a very successful test, and it was conducted by one of my former PhD students, Ryan Whitside, who's a fantastic young engineer. A scramjet propulsion engineer is his job at the company.
Very exciting times ahead for Hypersonix, Michael. Looking forward to seeing what the future holds. Can't wait for the next 5 years. Thanks for your time on today's Talkin Science.
No worries, Matt. Good to talk to you.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favourite podcast app 5 days a week. Just search for Trekzone and subscribe.